Okay, so now we are in 10.4, which is graphing trig function. So you did a lab yesterday. You either did the online one or you did the spaghetti noodle. My personal favorite is the spaghetti noodle, but I knew that not everyone would have the resources available, so I wanted to give an alternate. Makes me really miss the classroom though, because I really wish we could have been in the classroom to do the noodle lab together. So a couple things you need for graphing trig functions is vocab first. So amplitude. Amplitude is the distance from the x-axis to the maximum or minimum. So each part of the graph where the wave is, the amplitude is the same for each one. So like this amplitude is the same as this amplitude. So on the ones that you did yesterday, if you did the noodle lab, it was 1. So before we do any transformations, the amplitude of y equals sine of theta is 1. And then the period is the horizontal length that it takes for it to repeat. So 1 period is 1 up and then down. Or we'll look at some cosine later, but for sine, it's 1 up and then down, and then you can see it starts going up again, so that would start another period. Okay, so these are just in general before we add anything to it, like a dilation, or move it to the left, or move it up. So these are just in general. So yesterday you mainly focused on sine, and so sine is this orange one here, and so this would be 1 period, and our amplitude is 1 because it goes up to 1. However, you can use these little tricks to find the amplitude, the number of cycles, and the period for anything. So to find the amplitude of a sine function, you're going to take the absolute value of whatever number is being multiplied in the front. Okay? So amplitude, take the square root, the absolute value of the number being multiplied to sine. To find how many cycles in the interval, you're going to look at b, which is if there's a number in front of the degree angle. And then to find when it will have 1 period, you take 2 pi, divide by your b value from there. And we'll do some examples. Okay, cosine, very similar. For the amplitude, take the absolute value of a. For the number of cycles, it's still b, and to find the period, it's still 2 pi over b. So finding the amplitude, the number of cycles, and the period is the same process for sine and cosine. The graph looks a little different though. So let's jump over to some examples. Okay, so here's our first example. It says graph y equals 1.5 times sine of 2 theta over the interval 0 to 2 pi. So this interval right here, 0 to 2 pi, tells me what is going to be on my x-axis right here. So we can go ahead and fill this in. We know we need to go out to 2 pi. So I'm going to use the right angle markings on your unit circle. Pi over 2, then pi, then 3 pi over 2, and 2 pi. So this would be my 0, and then it goes out to 2 pi. Okay, then we'll go ahead and start by finding a couple different characteristics. So we'll find the amplitude, and remember that is going to be the absolute value of a. And remember, I'm going to move this up a little bit. We said in our notes previously that it's a times sine b theta. Okay, so our a value is in front. Okay, so our amplitude would equal the absolute value of 1.5, which is 1.5. So this is saying that the max is at 1.5 on the y-axis, and the min would be at negative 1.5. So again, these are on the y-axis. So that tells us that we need to go up to 1.5 on our graph. So I'm going to go up to 2 just to make sure. So this will be the highest it can go, so it won't go any higher than this. And then it won't go any lower than this. So our graph is going to be somewhere in between those. Okay, so now we know how high and how low our graph can go. Now we're going to go ahead and find the number of cycles. And we said that this is looking at B. So we're going to find our B, which is here. So that would be the 2 here. So when we're looking at cycles, what we're looking at is how many times it'll have one rotation or one period between 0 to 2 pi. Okay, so how many of these will it have between 0 and 2 pi? Well, it says B is 2, so there's going to be 2 rotations of this. So we're going to have something like this on our graph. Okay, and then the last thing we need to know is the period. So we want to, the period is going to find the halfway mark of this. And we said to find period, we do 2 pi over b. And we just said b is 2, so we have 2 pi over 2. Well, 2 divided by 2 is 1, so it's just pi. So this mark right here will be at pi. We know this is at 0, and then this will be at 2 pi. So now we know it starts here. We know that at this point right here, it's done one full cycle, or period, sorry. And then we know that at 2 pi it's back at 0, because again, these points right here would be the middle. Okay. Now we can look at, here is the first and here is the end. Well, directly in the middle is also has to be at 0. And then directly in between here, this one and this one, we have to have our highest point. And directly in between these two, we have to have our lowest. So one more time, we found the amplitude, which gave us the highest and lowest. We found the number of cycles, so the number of these, the number of each period that we're going to have between 0 and 2 pi, which is 2. So we said we're going to have one up, then down. That's one period. And then we're going to have another one. We're going to have 2 periods, 2 cycles. And it starts at 0 because we have our general idea that we graphed yesterday and we looked at the PowerPoint. And then directly in the middle of those is 0. And so now, whoops, we go up, down, up, and then it just repeats. So here, directly in the middle there, directly in the middle of these 2, directly in the middle of these 2. Okay, and it does go on, but it says only graph it between 0 and 2 pi, so we are done with that one. So I want you to go ahead and try y equals 2 sine of 0.5 theta. So pause and try those, or that one. Okay, so amplitude, absolute value of a, which is 2. So we get 2, so we can go all the way up to 2 and all the way down to -2. Okay, number of cycles, b equals 1/2. So we're only going to have half. We're not going to have this one. So we're going to have 1 up and down, 0 to 0. The period, 2 pi divided by 0.5 is 4 pi. So between 0 and 2 pi we got just half of 1 right there. And then the rest is here. So it doesn't start repeating until we get to 4 pi. So for our final graph, we start at 0 still. And we said we're only going to have this point right here, so I can only go up to 2. I know that at 2 pi I'm back at 0, so find the point directly in between the 2, which is pi, and that's right here. So our graph is just going to be like that, and that one is done. Okay, if you have any questions, please email me or Ms. Holstad. We're happy to help. Okay, so now we're going to look at a cosine one, and remember it's the same idea. It's just going to start at the higher point rather than at 0, 0. So I said to graph it 0 to 4 pi, so 0, 4 pi. Okay, amplitude, same idea. So absolute value of 2, which is 2, so I'm going to go all the way up to 2. I'm going to go all the way down to -2. Okay, then find number of cycles. Which is our b value. So the number in front, which in this case we don't see 1, which means it's a 1, because 1 times anything is itself, so we don't actually write 1 normally. So between 0 to 2 pi, we have 1 rotation. And this one looks a little bit different because the cosine starts up and then goes down. And we'll see that over here. So for 0 to 4 pi, we're going to have 2 rotations. Okay, and then our period would be 2 pi divided by b, which is 1. So 2 pi is when it starts rotating, repeating. Okay, so like I was saying, this cosine starts at 0, 1 normally, but since our amplitude is at to 2, it's going to start at 2. And it starts repeating at 2 pi, which means we're going to be back here. So find the middle point